Hello everybody, and welcome to this new episode of Velp Scientifica series of webinar. Today we are going to talk about fat analysis in milk, in whole milk, and in particular we will see how to enhance the quality of the dairy products. Before starting, let me introduce myself. I'm Mattia Mura, Marketing and Communication Specialist here at Velp headquarters. And together with me today, there is Vittorio Laghezza, Application Specialist here at Velp's Analytical Department. Today, we will start with an introduction to solvent extraction and in particular the importance of fat determination in whole milk. And then I will leave the stage to Vittorio, and with him we will see the analytical challenges and how to overcome these analytical challenges in the hydrolysis step, and then also in the fat extraction. And together with him, we will see how to ensure accuracy and reproducibility of results, how to work with solvent with safety, and of course, which are the instruments and accessories needed for an efficient extraction process. Then we will see together the results that we obtain. We will conclude with the insights that we obtain, and of course we will close the session with the question and answer session. So please write down your question using the chat box you have on the right of your screen, and we will answer to this question that we will receive at the end of the webinar or later by email. So after this brief introduction, let's focus on today's topic. As you may know, in recent years, consumers' interest in issues such as the origin of food consumed has grown considerably, and at the same time, reference regulation have also become stricter. So the need for producers, suppliers, and all the players in the value chain to increase product analysis in order to protect, on one hand, consumer health, and on the other hand, corporate image and integrity. In particular, within the food industry, the dairy one has seen a marked increase in quality monitoring in recent years, mainly due to the relevance of milk for people health. Today, milk is available in a wide variety of types, not only based on animal but also plant origin, but also on different processing methods, the treatments that you can see here, and nutritional composition. So let's briefly explore this main category to understand how milk differs in the marketplace. Starting from the origin on the left of the screen, as we said, we have milk based on animal or plant-based. So animal including options like cow, buffalo, goat, sheep, and so on, offering unique flavors and nutritional profiles. While on the other hand, we have vegetable milks including soya, rice, oats, almond, coconut, and so on. These options are especially popular among those people who are lactose intolerant or prefer dairy-free option for health or ethnical reasons. Then we have treatments, the treatment category, and milk indeed undergoes various processing methods to ensure safety, extend life, shelf life, or enhance certain qualities. These treatments include raw milk, which is unprocessed and typically consumed locally, where, of course, regulation permits. We have fresh pasteurized, fresh high pasteurized, microfiltered, we have high temperature pasteurized, we have UHT, we have sterile, we have milk powders and lactose-free milks that are also available, catering to specific needs like long storage and lactose intolerance. Finally, we have the composition category. That is because composition is another way in which milk is categorized based on the fat content, and this includes the whole milk with the highest fat content, giving a rich and creamy taste. Then we have partially skimmed, where some of the fat is removed for a lighter option, of course. Then we have the skimmed milk with minimal fat, often chosen by those people seeking a lower calories option. Each of these types is suitable for different dietary preferences and application, from drinking, of course, but also to cooking reasons. But today's focus is the whole cow milk, and in particular, if we consider this type of milk, we have this composition. Of course, the majority components are macronutrients. In particular, 87% of whole milk is composed by water, that forms the bulk of milk's composition. Then we have the fat content, in particular from 3.25 up to 4%, that the fat, of course, affects flavor, texture, and energy content. Then we have the proteins, more or less 3.5%. Proteins mainly are primarily casein and whey proteins that are very important for nutritional value and texture in dairy products. And then we have the carbohydrates that are almost 5%, that are mainly lactose, and they contribute to milk's sweetness and energy content. The remaining part of the components of the whole cow milk are micronutrients like vitamins and minerals that are essential for health and for boosting milk's nutritional profile. But why are we determining the fat content inside our whole milk? Determine the amount of protein and, of course, also fat is important for four main reasons. The first one is the nutritional labeling and compliance, because it helps providing precise nutritional information for packaging, labeling, assuring transparency for consumers, and compliance with food regulations. Then, of course, quality control, because determining the amount of fat accurately, it is important to ensure product consistency that is essential for maintaining customer trust and meeting regulatory standards. Then product development, of course, fine-tuning fat levels allows manufacturers to create products with the desired texture, flavors, and nutritional profile, such as also creamy yogurt and low-fat milk. And of course, lastly, process optimization, because real-time analysis enables quick adjustment during the production, minimizing, of course, waste and improving the efficiency. So now, before leaving the stage to Vittorio, let's delve into fat determination in milk. With him, we will see later that in order to determine the total fat in whole milk, a direct extraction with solvent is not sufficient and efficient, because a part of lipids is chemical bounded with other components. So the determination of the total fat content of this sample requires a preliminary hydrolysis using hydrochloric acid for N, followed by filtration and washing in order to free completely the fat molecules. Then the hydrolyzed sample is ready for the extraction, and it can be easily transferred from the HU6 to the SER158, avoiding, of course, any sample loss and ensuring the maximum accuracy of results. As you can see on the slides, our SER158 works in accordance with the Randall method, that is an accelerated and more efficient version of the traditional Soxhlet extraction method. During this analysis with Vittorio, we will see that we used 4 different solvents: the ethyl ether, the acetone, the petroleum ether, and the N-hexane, that have been tested individually to evaluate which is the most efficient one and which is the solvent that gives us the, let's say, best results, accuracy, reproducibility, and of course, which is the most suitable to perform this analysis and also to optimize our extraction time. Of course, to perform this analysis, we followed a reference method, in this case the ISO 8272 from the 1987. That is the method used to perform analysis on milk products and milk-based foods in order to, of course, determine the fat content in and it is a gravimetric method. Of course, we tested our samples using, as we said before, 2 different instruments. The HU6 to perform the hydrolysis step, as we said before, in order to free the fat molecules, while then the proper extraction, we perform this step using our SER158. You can see we have 2 different models, because in the slide you can see the model also we use to perform the analysis with 6 position, while here you can see the position with just 3 position, let's say. As we said, it is an automatic solvent extractor, because when we finish performing the analysis and of course the sample preparation, we load the sample, and then using the control pad we select the method, and we set all the parameters, and we press start. Then of course all the steps that include the solvent extraction are performed automatically by the instrument. Of course, we have also safety option in order to reduce at the minimal scale the exposure of an operator to solvents, as we are using solvents in order to perform the extraction. So thank you for the attention. I leave the word and the stage to Vittorio, and we will see later for the conclusion and to answer to the questions that may arise throughout this session. Thank you very much.
Thank you, Mattia, and hello everybody. I'm Vittorio Laghezza, and I am the application specialist here in Velp. Now we will focus on the analytical challenges tackled to how to make the process for the total fat extraction of milk. As introduced by my colleague Mattia, this process begins with the hydrolysis step. To start, glass crucibles are filled with 25 grams of glass sand and 3 grams of Salite 545. Ensuring the 2 layers do not mix. Depending on the sample's particle size, different crucibles with different pore size may be used. Altroid P1 is most commonly used. As you can see, this is the glass sand layer, and up we have the slide layer. Regarding the sample, it's crucial to ensure the homogenization before analysis. For this reason, liquid sample, for example, should be stirred before pipetting. For milk, it's possible to pipette 5 milliliters during stirring into a test tube. Then it's possible to add 2 grams of saline 545, and then it's possible to add 5 milliliters of 4 normal hydrochloric acid and shaking gently to homogenize the solution. Subsequently, another 50 milliliters of hydrochloric acid should be added to rinse any residue adhering the test tube walls. Then it's possible to place the crucible into the HU6 and connect to the aspirating tubes. Six crucibles could be placed onto the unit and each aspirating tubes connecting to each sample tube. One end of each tube should be securely connected to the crucible's ring, while the other end is immersed in the test tube. The system is set to 170 degrees centigrade for 45 minutes. Test tubes are inserted into the heating block and glassware is lowered. During the analysis, if foaming occurs, 4 normal hydrochloric acid should be added drop by drop to the test tube. At the end of hydrolysis procedure, gradually add to 150 milliliters of hot distilled water at 40-50 degrees centigrade to each test tube and turn the vacuum pump on to aspirate all hydrolysis residue into the crucibles. This step is critical to ensure complete sample recovery. Once washed, the aspirating tubes and crucible could be carefully removed. Using a spatula, it's possible to homogenize the slide layer with the sample to enhance the drying step, which is performed in an oven at 105 degrees centigrade for at least 1.5 hours before starting the extraction step. And now let's see the analytical challenges regarding the fat extraction. Before starting the extraction, it is essential to pre-treat the empty glass extraction cap by heating them in an oven at 105 degrees centigrade for at least 1 hour. Once cooled in a desiccator, their tire weight, named as M-tare, is determined with high precision, given the gravimetric nature of the analysis. Thanks to the crucible holder, it's possible to place the crucible directly into the extraction cap, into the SIR 158, without risking any sample loss. A crucial aspect of the extraction step is the choice of the solvent. For solvents were compared to evaluate their effectiveness, reproducibility, and selectivity in extracting fat from milk. This provides useful insights into choosing the best solvent based on specific analytical needs. Here is the list of solvents used, starting from the ethyl ether, followed by acetone, petroleum ether, and the last solvent is the normal hexane. All the operation of extraction process can be followed on the control pad of the SIR 158. It is possible to start the extraction under analysis menu, selecting a standard preset method, or it's possible to create a custom method, for example, named the total fat in whole liquid milk, where the user can set different parameters. We tested different parameters for each solvent. The best results obtained are reported in this slide. And as you can see, for the ethyl ether, the washing time is reduced at 16 minutes versus 19 minutes for the other solvents. Now let's focus on the results obtained. Here are the results we obtained, and as you can see, the average for each solvent aligns with the expected value. It is worth emphasizing the low standard deviation related to each solvent, with minimum standard deviation at 0.04 and the maximum at 0.08. So, in conclusion, the SIR 158 is an ideal solution to automate the extraction of total milk in whole milk, or total fat in whole milk, with consistent accuracy and reproducibility. The results demonstrate that the analysis of the total fat content using 4 different solvents yield consistent and comparable outcomes, with minimal variation in fat content and low standard deviation throughout a fully automated process. Among these, the ethyl ether proved to be the most efficient, reducing analysis time by approximately 30 minutes while maintaining accuracy and reliability. This efficiency is likely attributed to its high polarity, which enables the solvent to dissolve free and bound lipids. Thank you for your attention, and now I leave the word to Mattia.
Thank you, Vittorio. And while we collect the last questions, we remind you that you can also find an interesting webinar on nitrogen and protein determination in whole milk. If you scan the QR code, you can save the webinar. And in this webinar, we talk about Kildal and Dumas method for the dairy industry, comparing the two methodologies using Kildal or an elemental analyzer. We went through the analytical challenges, of course, starting from the sample preparation to the result comparison. And of course, we conclude the webinar, talk about implication, results, and so on. So we collected some